Hello students. So today we have this concept. You see, you have to calculate the equivalent EMF of this battery. You have to calculate what? Equivalent EMF of this battery. You know that a battery is what? A battery is a combination of number of cells. And the cells could be combined in various ways. So here the two different cells. One is of EMF E1, one is of EMF E1, internal resistance R1, the other is of EMF E2, and internal resistance R2. They are connected together such that their positive ends are connected together, negative terminals are connected together. Now, we'll be using this as a battery by connecting some device across PQ. Like when you connect some device across a battery, you connect one terminal, you connect from the positive terminal, and the other end of the device is connected to the negative terminal. So here, these are two terminals of the battery, P and Q. So you have to calculate what? You have to calculate the equivalent EMF of this cell. You see, this might be connected in this way also. Like the positive of this is in this side, and the negative of the E2 might be towards the P. In that case also, the method of solving remains the same. So look at this. What we'll do, we'll consider it as a loop. This is a single loop, and we take that this is the direction of current I. Now see, we take that there's a direction of current I in this. Now see here, of course, it will depend upon the fact that E1 is greater than E2 or E2 is greater than E1. So depending upon that will be the direction of current. So obviously here I'm taking that E1 is greater than E2. E1 is greater than E2. Examiner may give you this thing. If they don't give, you can also consider by yourself anything like E1 is greater than E2 or E2 is greater than E1. And depending upon that, you can match the option, correct option. So you see, now what we do, we apply the Kirchhoff's law, loop law for this loop. So let's say this direction is the positive direction. This is a positive direction. So in one side of the equation, we'll be writing what? In one side of the equation, we'll be writing the net EMF. That becomes E1 minus E2. Is what E1 will try to give its current in clockwise direction, sorry, anti-clockwise direction, and E2 will try to give its current in the clockwise direction. So net EMF in the anti-clockwise direction becomes what? E1 minus E2, because we're taking that E1 is bigger than E2. Now this would equal to I into R2 plus I into R1. You go in this direction, this will be what? I into R2 plus what? I into R. So through this you get I is equal to E1 minus E2 divided by R1 plus R2. Now sir, the meaning of equivalent EMF of this battery will be what? Because see, this circuit will always be on. This current will always be keep flowing. This will always flow. Even if you don't connect this device from P and Q to some other external device, still this current will always be there. Now, the EMF of the battery is what? When you don't draw any current from a cell, then potential difference across its terminals is called its EMF. So because we have not connected any external device across PQ, that means this, if we take that this is a cell, and this cell is not giving any current to the outside circuit, then in this condition, what will be the potential difference across P and Q? That will be called the EMF of the cell. So see, to get that potential difference, we start from the point P and go towards the point Q from the path from the lower circuit. So see, we do it like this, BP. This is what VP, potential of this point. Now see, understand this is a concept. Like if a cell comes on the way, then see what terminal of the cell is towards the Q. Is a negative terminal, so write it minus E. Would you understand this? I'm going from this path, lower circuit from P to Q like this. Now when a cell comes on your way, you'll see that if the negative of that cell is towards the point where you want to reach. You want to reach to the point Q, and negative of the cell is towards that point where you want to reach. Then this will be what? Minus C. Then if you're going in the direction of current, then potential will fall across R2. So that will be minus I into R. That will be called what? VQ. So students, this is slightly different than how you have taken the sign of I into R in applying the Kirchhoff's. Right here, when you want to calculate potential difference between the 2 points, so learn this. This is what? Start from the point P, reach to the point Q, select any path. You can reach from this path as well as from this path. Here we have selected this path, so BP. Now there comes a cell, and negative of the cell is towards point Q, so you write minus E2. You're going in the direction of current, so potential will fall across R2, that will be minus IR. Now you have reached to the point Q, so that will be VQ. So VP minus VQ will be equal to E2 plus IR. Keep the value of I, E1 minus E2 divided by R1 plus R2 multiplied by what? R. So this becomes, you see, this becomes what? VP minus VQ is equal to, this will be R1 plus R2 will be LCM. So this will be E2R1 plus E2R. And here we have minus of E2R2. So this will be E2R1 plus E1R2. And this will be called the equivalent EMF. This is the EMF equivalent. All right. This is equivalent EMF. So in whatever way the cell would have been connected, you apply the same process. Like suppose E2 EMF of this cell would have been towards right. The positive of this cell would have been towards right. Then the current I would have been E1 plus E2, E2 upon R1 plus R. Right? And reaching from point P to the Q, you will select any path while calculating the potential difference. And I told you how to get the potential difference. So what will be the potential difference between P and Q will be called equivalent EMF. Here in this case it is. And internal resistance of this battery R equivalent internal resistance will be equal to what? It will be equal to R1, R2 upon R1 plus R. And this does not depend upon the fact that whether positive of this cell is toward this side or the positive of the E2 is toward that side. Because see, R1 and R2, they are the internal resistance which are present inside the 2 terminals of the cell. So here also, this R2 is connected, this present between the 2 terminals. And because you're connecting one terminal together, that means you're connecting one end of the resistance together, and you're connecting the other terminal together, that means you're connecting the other end of R2 and R1 together. So they're always in what? In such cases, they're always in parallel. Does not depend upon the polarity of the battery. So because they are in parallel, there's an equivalent resistance. Hope you understood this concept. So this is the solution. All right, students. So all the best. Keep practicing the questions and keep clearing the concepts. All right, students.